Now that we know the requirements for our distributed file system, we can look at an approach for storing very large files. So our file system has to be fault tolerant. And so we want to look at how we can store and access very large files using cheap commodity devices. And the fact that they're cheap and commodity means we have to have fault tolerance. So an approach that was developed at Google by Sanjay Ghemawat and published in SOSP 2003 is the following. So we take our big file and we want to store it across a set of machines. For this example, we'll have 4 machines that we want to store our file across. So we're going to take our file and we're going to split it into smaller parts, and then we'll put copies of those parts on the different machines. So first question is, how do we split it? Ideally, we want to split at record boundaries so that an entire record fits on an individual machine. But sometimes you may have cases where the records are too big, and so you'd have to use a different approach to be able to find what part of a record is on a particular machine. That's out of scope for what we're going to look at right now. For now, let's assume each record can fit on an individual machine. So we take our file, split it into 4 parts, A, B, C, and D. And we'll take A and we'll make 3 copies of A and store it on machines 2, machine 3, and machine 4. Now, the number of copies, if we increase the number of copies, then if a machine fails, it means we won't lose our data if we have multiple copies, even if multiple machines were to fail. We'll take and look at that more in just a moment. Also, by having multiple copies, we can read parts of A simultaneously on machine 2, simultaneously on machine 3, and simultaneously on machine 4. So for each of the pieces of our file, we're going to divide it up and put it on a different set of machines. So we'll take B and we'll put our 3 copies on machine 1, machine 2, and machine 4. And then we'll take C and we'll put our 3 copies on machine 1, 2, and 3. And we'll take D, make 3 copies of it, and put it on machine 1, machine 3, and machine 4. Okay, so now we've split our large file across multiple machines, and we can easily support files that are massive. Right? These files could be terabytes or larger in size. We can read, as I said earlier, parts of the file in parallel. So we can read B on machine 1 while we're reading A on machine 2 and while we're reading C on machine 3 and D on machine 4. But we can also read parts of A simultaneously on machine 2, machine 3, and machine 4. So this means we'll have very fast reads even for very large files. Now, because we're building everything using our cheap commodity storage devices, we know that those devices are going to fail. It's not a matter of if, it's a matter of when. And if we have millions of disk drives in a cluster, and each of those disk drives has a mean time between failure of roughly 3 years, we're going to see a lot of failures of drives in a relatively small time period if we look at a time window. So we need to be able to handle failures. So what happens when we have a failure? So let's say, machine 1 were to fail. Well, if machine 1 fails, we still have copies of we can read all of the copies of our file. We can read A from machine 2, 3, or 4, B from machine 2 or machine 4, C from machine 2 or machine 3, and D from machine 3 and machine 4. In fact, even if we had another machine fail, like machine 3 failed, we still can reconstruct our file because A is on machine 2 and 4, B is on 2 and 4 also, C is on 2, and D is on 4. Now, if we had another failure, we would lose the ability to reconstruct our file. If we lose machine 2, we would no longer have any copies of C. If we lost machine 4, we no longer have any copies of D. So when failures occur, we're going to want to copy that data that we still have access to other machines to restore the redundancy that we had. So we have 3 copies of every piece of the file. Way more details. If you want to learn more about that, I recommend that you take a look at that research paper. Okay, so now we've looked at how we can take a file, break it up across multiple different machines. That gives us the benefits of being able to read that file much faster. It also gives us the benefit of redundancy. So even if one of our inexpensive components fails, we still have the ability to read the entire file.